People were talking about the stream key and power off. Keith said power off and power on. Funny thing is, that's actually what I had to do. I thought I was on air for a while. I was talking away and the stream wasn't going out. Turns out my ATEM had freaked out. It had gone back to like an old profile. It had an old stream key. It was actually streaming to an old live stream, I guess appending to the end of the stream or something. And then I couldn't even connect to it from the ATEM control software. So I ended up having to turn it off, turn it back on again. Very strange. So now, of course, I have done the intro once before and I am even more discombobulated than usual because I feel like I've just said everything. Hang on. All right, let's do a take two. Before I get into saying hello to everybody, hang on, I've got to quit out of things and open things and get myself back to the starting point. All right, here we go. At the starting line again. I acknowledge the traditional owners of this land, the Whadjuk Noongar peoples. I pay my respects to their elders, past and present, and to Aboriginal elders and peoples from other communities who may be taking part in this live stream today. So, what I was starting to say in my previous attempt at starting the stream was that I hadn't forgotten. I have been here getting ready, but I've been frantically trying to get the pick and place machine ready so we could do stuff on the stream, and I didn't. So I'm going to have to be doing setup in front of you, which is probably going to be kind of boring. But good morning to Chip, Austin, Stephen, Michael, Dave Paul Jones, The Lane, Russell, Keith. Good morning, Keith. Mitch said morning makers, but Mitch, I believe, is heading off to a Raspberry Pi event, so he's probably not going to be around. Peter Lawler is here. Don S, Dodgy, David Howe, Mitchell is here, and the text to chat, the chat to, you know what I mean. The voice is working. Who else do we have? Johnny, Johnny from Sweden, Dodgy, scrolling down. I'm not actually reading the messages at the moment. I am just, Gavin is here, Justin C. I am just scrolling down.
Mitchell R said test.
Haha, thanks, Mitchell. Who else? Cable Tie. Cable Tie is here. That's unusual, particularly on a really nice day like this. I thought you would be out on your bike, up Mount Dandenong somewhere, Cable Tie. Okay, let's see if this works. Michael says, oh, it's not going to work. Good morning again, Gavin. The voice is on another channel. What does that mean? What? Don't freak me out, Celtic. Now, Justin is going to do a test. Is it going to pick it up? Come on. It didn't say it. Why not? That should have allowed it, I think. Oh well. Okay. Take a deep breath. Take a deep breath. Center yourself. We can do this. Oh, I'm seeing 2 play requests.
Justin C said this is a test of the broadcast system.
Ah, okay. 2 tabs, 2 channels. I'm seeing 2 play requests from Mitchell. Right, there might be a second one open somewhere. I can't see it in any of my open windows. Maybe... Oh, I don't know where the other one is. I can't see it anywhere. Doesn't look like it's in any of my other open tabs. I don't know. Right. Okay. Where am I? All right. So last week I said that we might be looking at Amanda's presence detection project again. However, Amanda is busy today. She is doing some setup of something. There's an event going on. And did anyone else hear that? What are you talking about, Celtic? All right, I'm going to have to ignore the chat for a minute, or I'm not going to be able to get my thoughts together. Right now, the squirrels are running in random directions. I need to corral them, direct them, give them a mission and a purpose in life, and we can get some stuff done. So let's do that. So Amanda's project we might talk about another time, a follow-up time. In the meantime, I have, let's see if this works, I have these. Oh, they're upside down. And that camera, oh, that camera isn't turned on, I see. So let's see if that works. Is it going to work? Yes. Except that I'm not in front of it. That is the camera for when I slide across here to work on stuff on the bench. Back to here. Okay. So we have these PCBs, which are the version 1.1 OpenKayo. This is the version 1.0, which is, right now, one of these boards is what is running the machine, but with some patch wires and hacks on it. This is the board that should implement all of the fixes. I haven't even opened the packet. This is all still sealed. What I was up to was setting up the pick and place job in OpenKayo. And that, I think, is probably the thing that we need to do next. So, what I have, if I bring this up here, and I will show you in just a moment, so you can see what's going on. Now, can I expand that screen? No, I can't. Oh, it's doing screen scaling. All right, that's fine, that works. All right, what we have here is screen sharing onto the Ubuntu machine, which is running OpenPnP, and controlling the pick and place machine. Now, there are a few reasons that this could go spectacularly wrong. One of those reasons is that I have just done a major upgrade on OpenPnP and I haven't run a single job on it yet. So previously, I was running the stable release of OpenPnP, which was from March. I think it was, yeah, it was from March. And there hasn't been a stable release of OpenPnP since March, but there has been a huge amount of development, including, well, there's a, here are release notes here. Oi, what's that? Oh, I see. I clicked on the about thing, so it's opened a browser window. This is the, where is it? The big one is this one here, panelization. For some reason, even though I was running a release from March, it was not, it hadn't been merged, I think, and it didn't have all of this panelization stuff. So the whole logical hierarchy. Okay, backing up a little bit, let me explain this. Let's go on a little explanation of how OpenPnP does this. What you can do is define a job, and then within a job you can have PCBs. Or they're just listed as boards. So when you have a board, oh, there are a few there. This has changed. Interesting. Okay, so these are ones that it knows about, or that it has cached. So the OpenKayo board here, you can see that. Why doesn't it have any placements? That is strange. Ah, okay, yeah, this is all part of the new data hierarchy. All right, so the first version of OpenPnP, like early versions of OpenPnP, the data structure was basically that you have a job, and then within jobs you have boards, and then within boards you have placements. So each placement is a part, and it follows that sort of tree or hierarchy. Now, when you have a placement, say we look at placement C2 here, whatever C2 happens to be, it'll have an X coordinate, a Y coordinate. Let's see if I can bring this across so that we can see the actual values here. Come on, where is that? Where is it? There there's the column management on this is kind of annoying. So we've got X position, Y position. It's showing 4 dots there. Why doesn't it just show the value? Rotation, so we've got X position, Y position, rotation. It's got what the part is and what to do about if there's a failure on the part. There are a whole lot of things like that. So what we can do is define some of these parts. So we've got parts that are defined and we can assign them to placements. So fiducial 1, for example, I know what these are. I'm just going to stick fid 1, fid 2 and fid 3 as being the fiducial footprint. I'm going to change it from a placement to a fiducial, and I've already set approximately the board's location in the machine. But the really big change is panelization, because this is the limitation. In fact, I'm going to... Am I going to risk this? No, I'm not going to risk it. I was thinking of loading a panel job that I did a couple of days ago, but that was with the previous version of OpenPnP. So, okay, what happened was that you could have a job with a board in it, but if you have a panel, essentially you have multiple boards in a grid or in some arbitrary arrangement. And the way the previous version of OpenPnP handled this was that you would define a board and then you would define a grid with dimensions and offsets, and then it would replicate the first board. Now this is where the problem comes in. You would have C26, for example, on the first board. You might have 12 boards in a panel, so you would have 12 copies of C26. Now, what happened was its internal register of which parts had been placed and which ones had failed couldn't properly account for the fact that there were 12 copies of C26. So what would happen is, if you were running a board and it put down the first few C26s across the boards on the panel, and then one of them failed, and then maybe the next, I'll say a couple failed, and then the next ones worked, you would get to the end of the job and some of the boards in the panel would have C26 placed and some of them wouldn't. But that part had then been marked as successfully placed if it had gone onto the first board, I think it was. So if the first board had it, it would be marked as successfully placed. Or maybe if it was any board, I can't remember. I'm not sure of that behavior. It's kind of strange because it was a bit of an edge case that the original data structure was never really designed to handle. And then if you tried to get it to run again, to pick up all of the parts that it had failed to place, it would think the part was already there, and it would just say, no, the part's already there, even though C26 might have been missing from several of the boards in the panel. So one of the lead developers of OpenPnP introduced this new panels system, which basically adds another layer in the data structure so that it can keep track of failures within panels much better than it could before. And it also means you can have panels that consist of multiple boards, so multiple board designs in the same panel at arbitrary positions and rotations. So you could have boards at like a 32-degree angle and in random locations, and the system just, no, it takes care of it, it's fine. It accounts for all of the different origins and rotations and things. It's also got much better handling of panel fiducials compared to, or rather than just using fiducials that are on the boards. So overall, it's a big update, but it changes a lot of things about the way OpenPnP works. So I've been very hesitant to apply it, and it's not actually released yet. This is all still in the dev version, like in the test version. So I grabbed the test release, and that's what is running right now. That's what's in front of us. But the thing is that the test version, well, I have never actually run it. I've launched it, I've driven the machine around, as you can see. Like if I do this, we can move the machine. You can see the camera, the head of the machine is moving. I'm driving the camera around. We can go for a little walk across the PCB. So this is the OpenKayo version 1 PCB that I stuck in. Oops, why did I just turn the machine off? That was stupid. I was meant to click left and I clicked the power button and turn the machine off. Alright, I'll turn it back on, which means I'm going to have to rehome the machine. And this board is not in the conveyor. This is just in little board holder mounts sitting in the back of the machine, because there are no rails on it and there are parts up to the edge of all 4 edges of the board, which means it can't go on the conveyor belt. Alright, let's home the machine. Michael says it's all John and button failures today. Absolutely. Okay, so you can just see the thing updating as it's doing its homing routine, and then it goes to the front, and then it runs. See that? It's rotating each of the nozzles and doing run out compensation on the nozzle. So it's just done run out compensation on all 4 nozzles. That was not running on the board previously. That is a reasonably new feature in OpenPnP. I'm not sure if it was in the release version, but in any case, I have not had it set up until like yesterday, day before, when I did this update. Okay, we're making some boards today. Yes, Tradie, we are. Peter is saying lunchtime. Lunchtime. Yeah, I've missed lots and lots of the chat, so I'm sorry. I'm not going to try to go back and catch up. I'm going to try to make some progress on this today. Now, so this is the boring part. What I was doing right before the stream is I exported the PCB layout in Eagle format, and then I created a new job, I created a new board, I imported the board layout from the Eagle file. So this OpenKayo v1.1 board project here with all of these parts is a new import, but it doesn't have any of the parts assigned because I did not tell it to auto assign parts. Now, the reason for that, okay, the thing is that I'm about to embark on, Wagon Load says, look at my last comment. Okay, where is Wagon Loads? Scrolling back up. Okay, so Wagon Loads asked, can you make it so if it detected a failed placement, it will place a dummy part is an error footprint spot. It will place a dummy part in an error footprint spot. I don't understand that that question. Sorry, Wagon Loads. The failure handling in this is you can set retries per part. So if I come into parts, like just picking 120 ohm resistor randomly, you can see there is a pick retry count of 1, and there are multiple retry parameters. So yeah, max vision passes, so it can try. This is test when it does the optical alignment. It'll try it up to 3 times, and if it fails 3 times, it'll reject it. I probably could make that a smaller number, because if it fails the first time, it's probably going to fail the second and third times as well. And there is also a handling thing here. You see how it says on C1, it's got error handling alert. You can set it to defer. And if you have it on alert, then what it will do is actually stop the job while it's running and tell you that it could not place the part. And then you can manually decide what to do. Like you can stop the job, you can whatever, proceed. With defer, which is what I use now. So alert is default. With defer, what happens is that it keeps track of all of those failures, and then when it gets to the end of the job, it will tell you how many of the parts that it placed successfully. So down here it says placement 0 of 84. There are 84 parts that it knows about, and it'll get to the end of the job and say, down there it'll say you'd had a couple of failures, it would say 82 of 84. So you know there were 2 parts that failed. Then you can run the job again, and it'll only try to place those 2 parts. It'll just try to catch any of the failures that have happened. Yes. Okay, so Wagon Load says, dummy part is like a check mark that says this board has an error placement on it. Okay. Yeah. So where would it represent that? At the moment it represents that in this list of parts. So at the end of the job you can see which ones failed. Yeah, maybe we will get a live demo of that when it comes to placing parts. So this is where the boring part is about to begin. I need to tell OpenPnP what each of these parts is. And right now that is going to be a manual process. C0603, why is that there? Where is Design Manager? Hang on. Looks like Design Manager in footprint. Okay, yeah, Design Manager in Fusion 360 has just changed as well. So I'm going to remove that column. I'm going to remove that column. I can't get rid of that. Can I get rid of that? Value side pins locked. Sorry, you can't see what is going on here right now, but I'm just going to try. Okay, sort by name. Okay, C1 is a 1 microfarad capacitor. Now this part of the process, now what are we at? 2, 3, 4, 5. I'm going to make these all 10 microfarads. Now, if I had, this is the sort of thing that it's going to be really hard for me to do and talk at the same time. And also this is quite laggy because what you're seeing is screen capture on my local computer, but I'm running VNC. What you're looking at is a VNC window which is connected to the machine in the cleanish room which is running it. So this is being done over screen sharing, which is a little bit laggy. Where are we? C6. So no, that is, these ones are caps down to C8. Those ones are big electrolytics. I don't have those in the machine. 100 nanofarad. Where are we? C10. I've got a whole bunch of 22 picofarads. Oh, that's right. No, but I'm going to use 15s. So it specifies 22s, but screw it. Close enough. I'm going to make them 15s because that's what I have loaded in the machine. What are we going down to? We're going down to C15 is 22 picofarad. Now, what was I talking about? What I was talking about was if I told it to auto-populate parts, it would, now what am I doing, 16. It would try to, it would create dummy parts within OpenPnP that match the descriptions that are in the board file. And I've always been hesitant to do that. What's that one? That one is a 22 microfarad, and then I've got some 15 picofarads. So this is part of the process that I desperately need to optimize. This is prone to human error because, as you can see, I am just manually picking parts out of a list here. And I'm doing this, what is this, C20, that'll be a 10 microfarad. I am doing this by looking at the design manager in Fusion to see what each of these parts is. So it really should be automatically linking when I import the board file. Where am I up to? C21. So I've got a whole bunch of 10 microfarads here. There's a 10, where are we? There's a 10 going down to C24. They're all 10s. So the habit I've got into is I look down the list and I see what is the next part where it changes the value, and then I bracket and then work back up to the top. C25 is 1 microfarad, which is right next to 1 nanofarad in the list, so it's easy to get the wrong things. 26. So when I start doing this out of KiCad, I'm going to put in the effort to match up the part identifiers that come out of KiCad with the config in OpenPnP, so that all of this stuff gets assigned automatically. C27 is 10 microfarad. All right. Now what else is next? D1 is an SS56, and D2, D3, D3 is also an SS56, and D2, oh, that's a TCAN. Okay, that's a CAN protection chip, which is in my parts as ESD CAN 24, and D4 is, oh, that's just a little signal diode. I'm going to have to put that on manually, so I don't have that loaded. That is the voltage dropper on the supply line to the LED. Now the fuses I'm going to have to put on by hand because I don't have those loaded in the machine. We've got fiducials. Hang on, did I disable those electrolytic caps? Yes, I did. Alright. So what I've done is disabled these parts, because otherwise it's going to complain and say that there's a missing feeder and it won't run the job. Okay, so you can't see the other screen unfortunately, but I'm just dropping back down to here. Oh, USB, I'm going to have to find that. There's a 48 megahertz oscillator. I hope I have all these parts. I might end up having to take some off the... Yeah, I don't want to have to do that. Oh, that's the CAN transceiver. Do I have CAN transceivers in the pick and place machine? According to this, I do. So we'll risk it. I see 3 is the USB hub chip. I see 4 is a 48 megahertz oscillator, and then I've got a whole lot of headers. All the J's are the headers. I'll just turn all of those off. And L1 is an inductor I don't have loaded in the machine. That's for the power supply. LED 1. What is LED 1? That's a blue LED. Oh, which reminds me, there is a little Easter egg that I snuck into the PCB design before I sent it off for production. LED 2. Why are we placing an old version PCB instead of the new one? We're not. This is version 1.1, which is the updated one. LED 2, that is the WS28, blah blah de blah. And mod 1, mod 2. What is mod? Oh, that's where module. That's the I2C OLED that sits on top. And this is the Vroom 32S3 module. Alright, so now onto resistors. R1 is the CAN termination resistor. Oh, got to come down here. There. Which is a very large resistor. It's a 2010 footprint, specifically to give it lots and lots of wattage rating, to be able to withstand nasty things like 12 volts being shoved directly down the CAN bus. The resistor needs to be able to handle that. You can't just use a little 0603 resistor. What have I got? 5K1 and then 10K. It's unfortunate that these are out of order. I normally try to group 1K5. Do I even have that on there? No, I do not. Alright, I'm going to turn off R4. That one I'm going to have to put on manually. R5 is 1K. Oh, 6, 15K, no, go away. I think that was because of a Mac OS update that just happened overnight. R6 is 15K. Do I have 15K loaded? Yes, I do. Why 15K? That seems like an odd one. There are a couple of 15Ks. I think they might be related to the USB. What am I doing? 2K2, R9, 15K. I think they're like mode setting. I can't remember. R10, 5K1. So 5K1, of course, is the Raspberry Pi resistor. And 24K9. That is part of the voltage feedback setting, along with R15, which is a 64K9. Those two set the output voltage on the switch mode regulator. So what is R12? R12 is also 15K. R13, see, this is not ripping. R13 is 30 ohms, and so is R14. Those are oddball ones, once again related to USB. So this is, R16 is 100K. Oh, we're almost at the end of the list. We're just about ready to start putting some solder paste on, which is going to involve something interesting thanks to the amazing Mitch, and we will get to that. R17 is 10K. This process is so error prone. R18, I don't want to jinx it, but one of the things is that I am so aware that this process is error prone that I am kind of obsessive about it, and thinking back, I can't remember a single board where I've made a mistake in this setup and got the wrong part in its place, because I'm always looking and then looking back and then checking, was that really it? R21, 30R, R22, 30R. My eyes are going backwards and forwards between the two, and I'm checking in both directions. R23 is 15K. But one day I am going to make a mistake and put the wrong thing in here. 4K7, so that's the I2C pull-up. R25 is probably, no. Why is there only one pull-up? Oh, so we've got R18 is a pull-up and R24 is a pull-up. Yep, okay, so R25 is 2K2 once again. So I need to get automated part assignment working before the day comes that that's 30R and that's 30R. Okay, before, and switches, S1, that's it. VR1 is the LM38010, which I don't have in the machine, and VR2 is the AP2112K, which I think is in the machine. Let's see if it says that. Yes, it is. It says the feeder is ready. So that's a good sign. So we now have this. Oops. I just zoomed in unintentionally. Oh, that's a new thing. That wasn't working in the old version of OpenKayo, of OpenPnP. I just did a 2-finger drag and it zoomed. Alright, so that's it. Now, the board placement is really bad. Now, what you can see, I think I understand why there was that mention of assembling an old PCB. The PCB that is in the machine, I only put that in to be able to set the coordinates and get the little board mounting stakes in the correct positions. So before we actually run this job, I'm going to pop this PCB out. So if I run across here, yeah, I'm going to pop that PCB out and put in a real one with solder paste on it. So this is the OpenKayo 1.0 board. The dimensions are exactly the same, like the physical dimensions are the same, and in fact almost all of the part placements are the same. There are only a few variations between them. So this was just to have a board in place to get the machine set up. Now, next is solder paste, and I've been sitting on it to warm it up. So I need to get some solder paste on this board. And this is an interesting part of the story as well. Yes. What's next? Okay. I'm going to switch. All right, I've got to get off this screen and switch to overhead camera, because I'm going to show you something that Mitch did, which is really, really cool. Now, he wanted me to stress that this is an experiment. What he's done is made me a stencil by laser cutting mylar. Now, this is just an overhead transparency sheet. And normally when you put these in a laser cutter, what happens is that the heat of the laser burns the plastic, obviously, but it also causes problems. Let's chuck it under the microscope so we can really see what's going on. Which means I need to unplug that, plug that in, and then maybe we can get some microscope stuff happening. Is it going to work? Come on. Waiting for the microscope thing to boot. No, we don't have microscope coming through. I'm just going to power cycle the microscope camera, and then hopefully it'll come back, because having the microscope is kind of important for this. Oh, I see why it didn't come on. It's because I plugged the wrong thing in. This is it. Okay. Now we will have microscope action. Alright, but first I need to put something under it so that we can see. Oh, it doesn't really matter. I'll just get some focus happening. Where's a bit of it? And focus. Okay, so these are apertures that have been cut by the laser in the mylar. Now, as you can see, these are actually quite remarkably clean. Normally when you cut plastic like this in a laser, where's a pointer? Where's a pointer? This pointer is going to look like a huge thing under the microscope. Where, there, okay. So, if you look at the edge there of the aperture, you can see that it is reasonably clean. There isn't a big bulge. Normally when you laser this sort of plastic, it sort of curls up on the edge and you end up with a bulge, so the surface isn't flat. And then when you try to run your squeegee or whatever across it, like going, where's the edge of the squeegee? Right there. It catches on the edges and things don't run smoothly. But running this over this now, this feels really smooth. I'm not feeling any catching on the edges of these apertures. And that is because Mitch did a magic trick. So, the magic trick he did was with the mylar, before you put it through the laser cutter, you put a sheet of wet paper on both sides. So you end up with a sandwich of wet paper, then the mylar, and then wet paper again. You put it in the laser cutter, and then as the laser so the laser cuts through both layers of paper and the plastic, and the water in the paper absorbs energy and it keeps it localized. So it basically acts as like a heat sink on the surface, and it prevents the heat that the laser is applying to the specific part of the plastic from spreading to the adjacent part to the plastic and then making them shrink and curl up and causing all of those problems. At least I think that might be how it works. I don't really know. I didn't do this. Mitch did this. I sent him my design files and he is the one who lasered and generated this stencil. So this is an experiment in how to do low-cost local stencils very quickly. So if you have access to a laser cutter, this is a technique that might allow you to make stencils that come out a lot better with a much better surface finish than if you were if you just put the mylar straight. I mean, look how nice that aperture is. That's so nice. Oh, and okay, here is the torture test. A USB-C connector. Hang on, I've got to find it. Okay, there we go. You see those pads there, those apertures right there, those are the pins on the back of a USB-C connector. Now, this particular USB-C connector has pins that are, basically they're a pain in the ass. The pitch on those pins, I can't remember what it is, but it's not much. And being able to just solder them is tricky. So the fact that, and we're looking at this under a microscope, this is a fair bit of magnification. How do I get some sense of scale here? This is the edge of my finger, like just part of just the tip of my finger. This whole thing is tiny. Where's something else for scale? I don't know. I need a banana. I need to stick a banana under there. This is an M2 bolt, so not like M3 or whatever. In fact, is it M2? Might even be smaller. Yeah. So these are very small apertures, and Mitch has managed to cut it very cleanly and accurately. So I am really impressed by how well this technique has worked. Now, I'm definitely going to get Mitch on a live stream at some point. We're going to talk about KiCad and other things. Mitch has done all sorts of interesting projects, like his boat autopilot project. So we can talk about that. Oh, and this is the footprint for that would be the USB hub. Anyway, my point is, I am going to use this experimental stencil and we shall see how well it works. Now, obviously it is not going to be as good as a fully framed stainless steel stencil, because those are done with lots of, am I on the microscope or overhead? Overhead is what I want. Because those are put under tension. When they're fitted onto the frame, they are pulled very tight. They're like a drum, and the stainless steel has really nice edges on all of the apertures. So it's not going to be as good as that, but it should still be a lot less of a pain than doing this by hand with a syringe, which is what I did last time. So let's get out a board. Let's get out several boards. So the annoying thing about using an unframed stencil like this is just that it flops around all over the place. Now, which way does it go? It is that way. Cool, I got the orientation correct. Now I don't know if you can see, but see those little white patches just there? I'm going to chuck that under the microscope and have a look at what those white patches are. I think it's just discoloration on the surface. I cleaned this down a bit with isopropyl alcohol earlier. And where is that discolored section? I've got to find it under the microscope. Oh, what is that? Oh, that's on the bottom. Oh, it's just a little loose flake of paper. I probably should have a cleaner environment to be doing this on. My workbench is kind of dirty at the moment. Oh, okay, you can see a little bit of discoloration there. Oh, this is a good example. This is worth looking at. Grab the scalpel. Oh, it's got a broken tip. Broken tip scalpel. So you can see over here, the technique has worked very well. These apertures have ended up nice and clean. And over here, you can see that the surface is discolored a bit, and there is a little bit more, there's like a bulge around the edge of the aperture, because the plastic has pulled back a bit. So I suspect what happened is maybe This little patch of the paper might have been a little bit drier, or wasn't quite in contact with the surface, or something has happened and the technique has not worked quite as well right in that spot. I wonder if there's anything on the other side of it. So I don't know which side was up when this was cut. I might be able to tell by looking at the artifacts on the edge of the plastic, but yeah. No, it still looks fine. Like, there's not going to be any problem. I'll just get a knife under there. See, there's not going to be any problem with running the solder paste into that aperture. No problem at all. Yeah, this looks so nice. Oh, you can see little bits of fluff and things floating around. That's because my workbench is not clean. I really need to try to make all of this really super clean. Okay, it'll be clean enough for our purposes. Good enough for government work, as Dave Jones says. Oh, what does he say? No, good enough for Australia. Good enough for Australia. Now, technically it goes that way, so I should orient it to be correct. I want some other boards around it just to provide a bit of support, because I have this enormous squeegee, which is what I normally use on the stainless steel stencils. It's going to be too big for this job. So I'm going to chuck some other boards around. How am I going to do this? I better not get myself confused about which is the version 1 and which is the version 1.1 PCB. I'm just going to stick a bunch around and move that, stick another one there. Oh no, what I'll do is put that there and then I'll overlap these. And it's not going to be perfectly supported because we've got these holes in the PCB here, but I'm going to try to align it. Yeah, to do this in a better way, you would actually make a holder that has the aperture. So what you would do is have all of the outsides stuck down, and then you would have a cavity where you take your target PCB and drop it in. But I'm going to totally bodge this and just do this by hand like this.
Dodgy Brothers Engineering said, what stops you 3D printing a base with 4 pins in the corners and putting corresponding holes in the stencil?
Nothing stops me except time. That is, yeah, you also need, normally that sort of thing.
Says paper dried out due to the other holes nearby.
Ah, yeah, that's a good point.
Trady Trev says my workshop is a brothel compared to John's.
Well, mine is still pretty bad. So, okay, so the question about 3D printing and pins. Yes, you can do that. And hang on, I'll show you an example. All right, here is an example. This is a 3D printed base. This is based on Sion's vacuum stencil table project. You can see that there are locator pins in the corners. These holes are for the vacuum to suck the board and the stencil down, and it's printed to suit the outline of the PCB. So the PCB drops into the aperture and then the vacuum sucks it down. You lower the stencil in place, and it also gets vacuumed down because of the holes in the surrounding part. So the stencil gets stuck in place and held firmly so it can't move sideways. So that sort of locating system can be used as well. But printing one of those takes several hours. Who's got several hours? I'm going to... I just ripped the this bag, the bag that I have my solder paste in. Oh, I'm going to have to rip it properly. That's the end of that bag. I'm going to have to get a new one. Break out the solder paste. Before I do that, let's not be a bad example. I'm often really lazy about this. I will try to be a good example. And wear gloves. 1 hour remaining.
System notification. 1 hour remaining.
All right, let the examination begin. Yeah, we'll get this board assembled. Most of this is, so far, has been me screwing up the stream start and then blathering about OpenPnP and setting stuff up. Now, normally I would dump this onto the stencil. I'm going to do something backwards.
It's probing time.
Yep. I'm going to do something backwards. I'm going to put the paste on the squeegee. And I am very aware that this is not the recommended way to do it. But screw that. I'm doing it this way. Now, one of the things about having a transparent stencil is that it is actually really hard to see the alignment because you can see through everywhere, not just the apertures. I think that alignment is pretty good, but let's find out. All right, so what I'm going to do is, it's slightly off camera, but I'm going to, my left hand here, I'm going to put down on the stencil and clamp it in place. And then I'm going to put the squeegee over this way, run it across, and we will see if we end up with solder paste on the PCB in the correct locations. All right, take that off. I've got to think about how to do this. I'm going to curl the stencil up. I've got to try not to bump it sideways. So I'm keeping it clamped down.
Why follow recommendations, lol? The stencil needs some laser printing for location alignment.
For location alignment, yeah.
Trading Trev says he's got the gloves on.
There we go.
I've cracked a beer. Let's go.
Enjoy that beer, tradie. All right, now let's check the quality of the paste. And we want microscope. Hang on, I'm going to zoom back out a little bit. I've got a bit too much magnification happening, so we don't have enough context. All right, that looks really good. Like, this is the back of the USB connector. Oh no, that's not. That's the quick connector. Apart from my slight misalignment that you can see, look at the shape of the paste on the pads. That is really nice. Yeah, I was slightly misaligned there. This is definitely adequate. Like, perfectly fine to be using this like this. Yeah, look at that. Very good. And it's got the all the pads there for the TQFP. This, I have to rate this as a total success.
Tradie Trev says that turned out better than I expected.
Yeah. Now look at this. This is the worst case part of it. This is the back of the USB-C connector. I think that it's probably put down a little bit more paste than I want, possibly due to the thickness of the plastic. You can see there, and I'll see if I'll zoom in and then get a bit of focus again. Bit of focus. And I'll stop bumping the microscope so that it settles.
Regulo says, tell it looks close enough to work.
Yeah, it does. That's really nice. I suspect that I'm going to end up with solder bridges across the back of this USB connector because there is just too much solder paste on it. So maybe the apertures could be made slightly smaller to compensate for the thickness of the plastic. Enhance. Yeah, we need voice control. Now I'm going to, what am I going to do? Later I'm going to add a little bit of solder paste into these holes because those apertures weren't opened on the stencil. So I'm manually going to add some paste into those holes. It's called paste in hole. And believe it or not, that is actually the term that people use. So paste in hole application is when you put solder paste into through holes and then put leads in. In this case, it is just the mounting stakes from the USB connector. And there's the WS2813 LED. Yeah, this has been a legitimate success. So I was going to assemble several of these boards today, but I am only going to assemble one just for time reasons. So I'm going to take these other boards, move them out of the way. I'm going to have to sort them later to divide which is version 1 and which is 2. I am not going to clean the stencil right now. I'm going to get on with doing assembly, but I'm going to get the, I'm just scraping the solder paste back into the tub, which is probably technically not recommended either, but I would go through so much solder paste if I didn't reclaim the unused paste off the squeegee. Oh.
Tradie Trev says it's a different method that I've seen. Bit of wick would sort it out the bridge joint.
Yep, that's right. So I'm going to have to do a little bit of rework on bridges on the back of that connector, I'm fairly sure. Now I'm going to put the stencil and the solder paste and the squeegee off on the other bench out of the way. Otherwise I'm going to knock it and get solder paste on things. So later I will come back with the IPA and clean all of that up. But for now we have a pasted board. Next step is pick and place. Now for that, I'm just going to see if I can wake up my phone. Come on, can I log in? Because I should have Droid Cam running to allow me to go mobile. Let's see if we can go mobile. That. Yes. All right. Let's go mobile. I'm going to take... Ooh. I'm going to take the board. Where can I grab it without touching any solder paste? There, I think is safe. So, oop, past the washing machine. Can I do this without dropping everything? Oh, that would be sad.
Turn speaker volume up so you can hear say better in room.
That's a good idea. I need a speaker in here as well. All right, coming around, you can see that that OpenPnP there is set up, and I'll open up the machine, and in the back of it, oh, I'm going to have to move the head out of the way. Okay, so I'll put that board down. The head is currently located over the PCB, and that is going to make it really, really hard to reach. So I'm going to park the machine, which moves the head over to the back right. Pop that board out, and we'll put our pasted board into the same location. I'm using these. So these holders are actually not meant for holding PCBs. They are designed for holding trays of parts that you can put in the back. Because sometimes when you buy things like ICs, they come on trays. And now, how can I arrange this so that we can see both the... Yeah, the door kind of gets in the way. All right. I couldn't hear what that was. Someone said something.
Peter Lawler says unclean, unclean.
Unclean? First person PCB placement, yeah. All right. Now, watching the screen. Oh, I'm going to move the camera up really close. Watching the screen, I'm going to go to the board location, and you can see that it's off a bit. So what I'm going to do is 2 passes. First I'm going to change to 1mm increments, and I'm going to jog the camera to put it approximately at the origin, and then capture that location as the new origin of the PCB, and that resets all the coordinates. But now to do an accurate alignment, what I'm going to do is find the fiducials I'm not going to run automated fiducial alignment, but I've got the 3 fiducial selected. I'm going to select footprint based alignment. I've already got those selected, so I'm going to go next. And the fiducial is not quite aligned, so I'm going to go to 1/10 of a millimeter step, move it to be aligned with the fiducial, approximately that way. No, I'm going to go down to 100th of a millimeter. All right, move it and go to the next one. Back to 1/10 of a millimeter steps and align it. Yep, that looks good. And then this one, align that one. That looks good as well. All right, finish. So that has now reset the coordinates based on those fiducial locations. So if I pick a part like D3 and drive to its location, the coordinates should be accurate. And if I drive to R7, the coordinate is accurate. So it now has all of those positions. Oh, I know what I forgot to do. I need to do a select all and then change the error handling to defer instead of alert. So now if it hits an error on any part, it's going to just keep track of that and then move on to the next one. And then at the end I can pick up any parts that it has failed to place. So next I am going to, all right, what I'm going to do now, just so that I can do camera mode switches, is I'm going to drive this from my computer in the other room. But first, I'm going to open the door and move this camera into a position, hopefully, where you can see what's going on. Oh, so this is going to mean temporary seasickness mode because I need to move the tripod to, oh, come on, can't quite reach. I need to move the tripod to get it into a position where it's down closer to the machine. And in there, and can I zoom? Oh, I can zoom, okay. Right about there. Okay, now I'm going to walk into the other room because I want to be able to flip to the screen capture mode. So now I can switch between this, which is the live view of the control software, and this, which is the live view of the machine. So starting from here, if I click go, so let me just check the air compressor is running. I'm doing the mental pre-flight checklist because once I press go, it's going to start moving very quickly. Don't need to enable feeders. I've got all of that defined. Now this is actually the first board that I will ever have done using this test version of OpenPnP. So this OpenPnP is not the release version. This is like the development version, and it may all go horribly, horribly wrong. Let's let it rip. I'm going to click go, and then I'm going to switch between the two views so we can see what's going on. So go, and you can see it's moving around there. Oh, it just got a failure on a part there. Oh, it's got a failure on another part, I think. So I'm going to switch to this view, and we can see the machine moving around. Oh, that was the WS2812. You could just see that it picked it up. It was large enough that we could see it.
Peter Lawler said, "Let the blue smoke escape."
Yeah, it seems to be failing on all of the parts on nozzle 1, which is interesting. So if I switch back to this view, you see how it's drawing that very big bounding box around it. It is totally screwing up what it thinks the part location is. So I may have to, and this is unfortunate because this nozzle is the one, oh yeah, it's picking up parts, but its image processing is way, way off. And that is the nozzle that is used for 0603 and yeah, you can see it's rejecting every part, even when it is successfully picking it up. You see the 3 flashes of the light down in the bottom of the screen. That's it doing its 3 attempts at optical alignment. Yeah, I'm just going to let it do its thing. It's going to fail, but what I need to do is yeah, the only parts that it's managed to place are the ones that go on the other nozzles. So what I need to do is have a look at the vision pipeline on, yeah, we may not get this board assembled today because this is screwing up so badly. You can see that there's a part on the nozzle tip there, but it is rejecting it, and the bounding box that it's drawing it just doesn't make any sense at all. I don't know why it's doing that. Oh, I see why. You can see that it's aligned with the nozzle. See this part here? There must be a graduation of some kind on the lighting, and it's doing its so it's detecting a rectangle aligned with the rotation of the nozzle, because it's got these 2 flat parts on the nozzle, and that's what that box is aligned with. Alright, so let's stop this job because we're just wasting parts at this point. So the thing to do now is Wagonload says, can I tell it not to use head 1? Maybe I could possibly get it to use the second nozzle. The nozzles are different sizes, and the second nozzle I don't normally use for 0603 parts, but I could possibly make it compatible. So that is one way to do it. But what is more beneficial in the long term is fixing this vision problem. So the way to do that, this is a bit of, let's see, if I find a part, I'm going to pick a part, one that I don't use all that often, so it doesn't matter if I waste it. Not that it matters. I just replace the reels anyway. Right, let's try 64K9. I'm going to pick that part, ba-chunk, and that part should now be hanging on the nozzle. And if we switch back to the phone view, and well, it doesn't really show us anything. The machine's just sitting there hissing away holding the part. So we can tell a whole lot more by looking at the OpenPnP interface. Now if I go into, so we've got this vision pipeline stuff here. If I do vision packages, now if I go to R0603 and vision, bottom vision settings, can I make this a bit smaller? I want to see if I can drag it across so you can see more of the right hand side of the screen. No, not really. Okay, so that particular resistor that's loaded on nozzle 1 is the R0603 profile, and there is a vision profile for this. So if I click on test alignment, what it's going to do is try to run its vision pipeline. So I'm going to click on that, and you can see here that it's complaining. Width was too large, nominal 1.7 millimeters, because it's an 0603 part, and limit 2.198, that's the maximum, and it was measuring at 5.337 millimeters. So it thinks the part is way too big, and the way it's detecting it, it is way too big. Now if I run test alignment again, we will see momentarily that it overlays the box where it thinks it detected the part. Now this is where we can do some fun stuff. So if we go to edit the vision pipeline, do I want to move the nozzle? Yeah, it's already there, but so what? So this is showing us what it thinks it has detected of the part, and these are the steps that it went through to get there. So it starts off with each of these steps. So this was the image capture that it did, and you can see that it's got the part mounted on the, loaded on the tip. The rotation is quite accurate, and the positioning looks quite accurate. It's centered on the tip, and it's nicely horizontal, so it's obviously rotated to like a good position. So that is a very clean pickup. The problem is just the detection. So then It does the debug right, then it applies a Gaussian blur. Don't know if you can quite see the difference between that, but it's applying a little bit of a blur, and then a mask circle. So with the mask circle, it is removing all of the background, and we can specify the diameter of the circle. In fact, I'm doing 2 mask circles. There is the default one. This pipeline has been edited. There is this mask circle is derived from the system-wide settings. This is one that I manually added that has a diameter of 200 pixels, I think it is. And then we do a convert color, a mask HSV, and a threshold. So it could be anywhere down here where it is screwing up. So then we switch to black and white, fine contours, filter, mask circle again. Why is that? Draw contours. Okay. So at this point, we are getting circles appearing here that should not be there. So by this point, it's already screwed up. So minimum area rectangle, and then pulls back the image, and it draws the minimum area rectangle that it thinks will fit around that part. And you can see that that is based on this, drawing the contours. So why has it detected, you can see that it's detected the part in the middle, but it has also detected these 2 circles, and one of those is this edge, and the other one is this edge. So why? Why has this changed compared to the old version of OpenPnP? Maybe what I should do is reset, copy the pipeline to the clipboard. I'm kind of tempted to reset the pipeline to default and let it and see if that works any better. Yes. Does your vision?
Norma said, "Yay pre-release."
Yes, yay pre-release. So Wagon Loads asks, does the Vision have a scale setting? It does, but it is in the camera configuration. What happens is that in the camera calibration, it allows, it calibrates X and Y pixels per millimeter scales, rotation, and also fisheye compensation. So it does image distortion compensation based on the structure of the lens. And all of that is calibrated out using test patterns that are loaded and then processed. But that's in a different part of the setup. That is in the setup of the raw feed from the camera. So, minus 20 degrees Celsius. Say version 0.99. Yeah, this is a Git, like a Git an auto build out of Git. I don't think there's anything wrong with it. I think it's just because things have changed. Alright, so somewhere, convert color, BGR to grey, find contours, and somewhere down here, draw contours. So find contours, it's this stage here where it is screwing up, but it is screwing up because of something that is happening prior to that. So let's just try, just as an experiment, I'm going to disable my mask circle and I'm going to rerun the pipeline, and then we're going to come down to the end, and now you can see that it has discovered, like if we come back to contours, you can see that it's seeing a whole lot more. It's seeing more of the outline of it because it hasn't been masked out by that circle that I was applying earlier. So there should be some thresholds and things that I can adjust, but I'm going to turn my mask circle back on and then rerun the pipeline, and if we come back down we can see that it's now eliminated. Oh, but it's got different lighting here. It's now eliminated the outer circle. So there should be there's normally a threshold. Where is the threshold? I'm gonna try adding a threshold filter in here somewhere. Now where is it? It does that. Convert color, mask HSV, mask HSV. Oh, the threshold is being set here. Why is that threshold set to 255? That is really high. Saturation max, hue max. Let's try. So maximum saturation to be masked. Saturation ranges from 0 to 255, and hue max, last hue to be masked. Yeah, that is strange. Yellows fall in a range, greens to 64 to 107. I think this is where it's screwing up. It's not applying its green screen filtering. So let's change that value from 255. Let's just put it down to 100, because it should be doing like chroma key filtering on this and removing the green from the image. I don't think that made any difference whatsoever. It just made it worse. So fine contours, where was the, oh yeah, mask HSV, saturation max. Let's change that back to 100 as well. And rerun. Nope, that's not really making any difference. It is totally failing to mask out the green. So the color that you see here, this green, this is the plastic surround on the nozzle tip, and it is deliberately done as green so that the software can apply a green screen function effectively. So just like when you're doing special effects in a movie and actors work in front of a, well, these days typically it's a blue screen, but either a green screen or a blue screen, and then that color is deleted to make it be possible to fill it in with whatever you want. The vision software in pick and place machines does the same thing. What you can do is filter out that specific wavelength of green and just make it vanish. But that is not happening here. So I'm just going to try some different values, some wildly different values, to see what happens. And it doesn't seem to be making any real difference. So why is, oh hang on, fine contours. Oh no, okay, no, it was before the color conversion. That's alright. Auto fraction, what does auto do? Let's just turn on auto. Pixels falling in and around the channel's histogram peak bit are masked. Okay, so let's change this back to how it was. You can see that I'm just kind of fiddling with stuff at the moment. I'm not doing this in a very scientific way. I'm just screwing around right now. So I've set hue max and saturation max back to what they were. I could have been playing around with hue min and hue max, hue min and saturation min as well, and I've just turned on auto. So I don't know what auto does, but let's just try running it and see what happens. Image recall, nope, that didn't fix it. Alright, threshold, mask HSV, convert color. Now where was that threshold? Oh, this is the one. It's just changed all the values to the hues to -1. That does not look right. I don't like that, so I'm going to change it to hue min. Oh, maybe that just means that it's, I'm going to set these back to the values they were. 255 and 0 and 255. Value min, I don't know. Set to be masked, minimum value to be masked. Setting value, blah, well, revolting, I don't know. Oh, excuse me. Hopefully I've got that back to kind of where it was before. And yep, still not working. Now, is the nozzle green clean? Reasonably. External, yeah, okay. There are some good questions here from Wagon
Mitchell
Loads.
R said try Hue 120, 100 minutes, 130 max.
Yeah, cool. Thanks, Mitchell. So what that would do is set a bracket.
System notification. 30 minutes remaining.
Yeah. So what Mitchell is
Mitchell
suggesting.
R said saturation 100.
Saturation min 100 and max 120. Oh, hue 100 to 130. Okay, so I'll try saturation. Oh, yeah, whatever. I'll just try that. So I'll try hue. The hue is the critical thing because that is setting the color that it cares about. I'll set that to 100. I've just screwed around with saturation as well, but haha, so what? Well, let's just try this and see what difference it makes, if any. Threshold results. No, it's threshold. We should be seeing the effect in here. It should be disappearing. Hang on, why did that go to auto? Threshold? Why? Oh, and there are two mask HSV filters in here. What? Oh, this must be one that I added. So mask HSV, that's not doing anything. Okay, this one. Turn auto off. Let's try this one again. Hue min. Hue min. Let's go from hue 100 to 130. Now, what was it saying is green? So where is green? Greens fall in 64 to 107. Okay. So 64 to 107. How about I change that? I'm going to use the 64 to 107 as the hue to filter. Saturation, I'm just going to leave this as 0 to 255. And oh, okay, Mitchell said HSV for green is 120 degrees, 100%, 100%, so around about the same.
Peter Lawler said if you don't eat your greens, you can't have any pudding.
That's true. All right. Run it. Run it. I'm not seeing any differences appear in here when I run it. Saturation. Min and max keeps changing. Value min. What is value? What does it think value is? Minimum value to be masked. Note values range from 0 to 255. Setting min value greater than max value will result in no pixels being masked. Setting value min greater than value max. Alright, let's try setting this to 120. Oh, pipeline control value. Okay, I'll just set it of 100. Yeah, okay. Nope. Saturation max. Why wouldn't that stay at 255? Maybe because I just hadn't clicked out of it?
It is changing it live on the image on the right. So I don't think you have to worry about saving to test and see.
Oh, okay.
The green on the right IMG should disappear.
Yes, that's right, it should. So when I've played around with this in the past, that has been the case. I've been able to see the effects in here. So
Cable Tie said, can we compare with one that was working to see what success looks like?
Maybe, but the that is a very good point, Cable Tie. Checking with one that's working is a good idea. So let's have a look at save. Yeah, I'm going to save it. Let's have a look at the vision pipeline for 0805 because I think that one. Do you want to move? No. Because I think that one just put some parts down. So mask HSV, I think this is the critical thing. Mask HSV. So in here I've got 64 to 107 and value min 50. Okay, 64 to 107. That's interesting. So this is in the pipeline for 0805 parts. So 64 to 107, let's close that and go back to the 0603 pipeline. No, it's already there. Threshold, there, 64 to 107. Yeah, so that is what I have just changed it to, but the saturation max was different. Let's just try changing saturation. Ooh, you can see that a couple of things just went away. Let's try changing this, making this a low value. Let's see what happens. Value min. I can't remember what that was set
Mitchell
to.
R said I posted a link to the OpenPnP docs for this for more info.
Yep. Yeah, this is one of those things where I could spend a while sitting here looking at the docs again, because it's a while since I've played with this. But it's probably not all that much fun to be watching.
Mitchell R said I posted a link to the OpenPnP docs for this for more info.
Yes. Thanks, Mitchell. Wagon Load says, can you copy 0805 settings to 0603? What I could do is create a new pipeline from a definition on a clipboard, copy the pipeline, so we can copy and then make a new 0603 one. That is it's not that simple, unfortunately, because I can't just replace a pipeline. So, what I can do though is I'm going to copy the pipeline as it currently stands to the clipboard. Now I need a note program or a text editor or something. Text editor, there we go. And then paste.
Mitchell R said try hue min 60 max 130 sat max 255 sat min 0 val 0.
Okay, I will give that a shot before I reset to default, which is what I was just about to do. So what Mitchell suggests is hue 60 to 130. So at the moment I've got 64 to 107. So I'll do 60 to 130. 130, and sat max is 255, and value min 0 to 0, value min 0. All right, let's try this. Nope, I'm going to rerun anyway just to be sure, but no, it doesn't look like that did it. So what I'm going to do is, now that I've got the existing pipeline copied to the clipboard, so I can get that information back if I want to. Save? No. What I'm thinking of doing is just resetting this to the defaults. So you can't quite see it, but there is a little button. In fact, I'll get rid of that. There is a button here which is reset to default, and I am going to click that. So part of the issue here is that I have just done this change from the previous version of OpenPnP, and the pipelines may be a bit screwed up. So I'm going to go reset to default. Are you sure? With 2 question marks. I am doubly sure. Yes. All right. So that is now reset to the default pipeline. And if I now go into edit pipeline, I'm curious to see what we find. Yeah, move the nozzle. All right. So that has totally screwed up, obviously.
Mitchell R said apparently it has a calibration system built in for this. Maybe we can try that?
Yeah, like an auto calibration thing. Yes. So I'm just going to... Ooh, look at that. This one is doing way better. I think I can fix this pipeline just by adding a mask circle stage. Contours? Yeah, look at this. This is... The default pipeline is doing way better than the other one was. Despite the fact, see this huge rectangle? Despite that, it is actually doing better. And the reason I say that is if we come back down to fine contours, like down around here, where are we? There, you can see that most of it is gone. So if we add a mask circle stage up here, so here it's got a mask circle which is derived, like it's a large circle. but I am going to add a new mask circle stage. Where is it? Mask model. Why isn't, what? Mask circle. It was right there and I just couldn't see it. Alright, so mask circle, where did it put it? I'm going to move that one back up the pipeline a bit. Mask circle, I want to put it directly after the factory mask circle, and I want to set its value. Come on, why can't I set the value on that? Property name of the property, use mask circle for standard control. I don't want mask circle, I want, no, not property name, I want diameter of 200, which is what I had previously. Okay, so now if we come down to here, apart from these little artifacts up here, this is actually now really close. So if we do contours, we can see that it's got the part apart from that little artifact, and that artifact will be a reflection of, it's that little part there. You can see where the black is just slightly brighter, and that is going to be pretty easy to get rid of. So already we're in a better place than we were before. So if we come down to the end result, you can see the rectangle is tighter. It's skewed because of that little artifact, but that artifact can be fixed, and that can be fixed in camera settings for brightness, I believe is probably the best place. So I'm going to save that change, go into machine setup, bottom camera, general configuration, where are we? White balance, device settings, brightness, it's currently set on -61. I want to turn on, where is the bottom camera light? Can I turn it on from here? No, I can't. Damn. Alright. No. I'm just going to have to take a guess. So it's currently on -61. I'm going to take the brightness down to about -75. That'll do. And go back to vision and edit that. Yes. Oh, it didn't fix it. Didn't fix it quite. We still got that tiny little artifact there under machine setup. Okay, I think I might go and do the machine setup calibration thing. Oh, it did actually improve it. You can see that that little artifact is smaller than it was before because I turned the brightness down. I'm going to turn the brightness down more. Machine setup, blah, general configuration, device settings, brightness from -74, I'll make it like -87. Back to vision, edit, yes. Ooh, there we go, that got it. It removed that little artifact. So this is a sample size of 1. So, oh, it's really borderline on detecting that edge now. This is a sample size of 1, so it we may still have some tuning to do, but this is at the point where that is actually kind of working. So I'm going to close that, go back to the job. We're going to do special discard, throw that part away.
Whoop.
And Michael says, is there a remove random artifacts button? There should be. Alright, so let's see if the camera is still running. It is. So the nozzle is in the down position right now because it just threw that part away. I am going to click go again in OpenPnP and we will see if it continues. So it's picking up some parts. Oh, just put a part down. It failed on a part on the other nozzle, which is interesting. Ah, okay, there was a problem that just happened then. You wouldn't have been able to see it, but it mistakenly thought that it had picked up a part when it hadn't. So this is looking back at the OpenPnP interface. You can see it's detecting that part, and you can see the vision is quite dark now because of the brightness being turned down on the camera. I think it is worth doing that setup process, and you can see that it's finding the bounding box on these parts. But there was a part, there is
15 minutes remaining.
There was a part a moment ago where it thought that it had picked it up and it hadn't, because it detected a tiny little artifact on the nozzle. So it's still not 100%, but it is kind of working now. And you can see that the vision is quite dark. It's fairly normal for machine vision systems to have very dark vision. See there, it just detected a failure. You can see that it flashed 3 times because it was looking for a part and it could not find the rectangle. But so far, this is going okay. There are going to be a couple of parts that I still have to put down by hand, but it's getting there. I wonder what happened with the failure on nozzle 4. That is something else that I'm probably going to have to tune. So I might have to go through the vision pipeline settings on all of the nozzles and get them all working properly again. Oh, it just screwed that up. You could see that the alignment was way off on that transistor or whatever it was. Might have been a transistor. No, I think it must have been the CAN protection TVS, the transient voltage suppressor. Oh, that one was a bit off as well. Yeah, and that one is way off. So this pipeline is definitely not working as well as I had it working up until a day or two ago on the old OpenPnP. So I'm going to have to screw around with that. Now while this is going, machine setup. Oh, I think it kind of thought it's finished the job. So it's missed quite a few of the parts. Okay, here's an example. If we look at this, so C17 is a 22 microfarad capacitor. 22? I thought I only had 10s loaded. Oh, I screwed that up. I should have made that a 10 microfarad. That's why it failed. The 22 microfarad feeder is actually empty. And you can see here it's marked as, oh no you can't. You can see here that it's not marked as placed. These other ones are marked as placed. This one is not placed. So that's why that one would have failed. It would have tried to be picking that up from a feeder that needs a new reel in it. But there are some 10 microfarads here that failed, which is interesting. And what else? It failed on, oops, yeah, it failed on picking up the CAN transceiver, and it failed on the voltage regulator down here. So there were a few failures, which I think some of them were at least due to that vision pipeline. Some of those had actually got passed before I started editing the pipeline. So machine setup. Let's have a look at the at this. So Mitchell was suggesting having a look in. Wagonloads asked, is the artifact caused by a reflection on the tape the part is loaded from? Possibly, and also possibly because I've got the cover open on the machine at the moment. So right now, that is my phone sitting on a tripod looking into the machine and the lid is open. So yeah, there could, and the back lid is also open. So there'll be light coming in from other places that it probably shouldn't be. So, oh, not there, there. Now, what was I doing? Vision, okay, vision. Not bottom vision. Where is the setup on this? Is where it was saying, oh, in nozzle tips, okay. In nozzle tips, here, part detection, and tool changer and calibration. Okay, here we go. Background calibration, method, brightness and key color. Yep, that's what we want. minimum detail size, a whole lot of stuff there. Pipeline edit, machine home, calibration, calibrate. Calibrate camera position and rotation. Oh, that's different. That's not the bottom vision. That is the position. But down here, this is interesting. Okay, so non-sufficiently keyed, blah, blah, blah. Show problems. Let's just click that button and see what happens. Does not indicate any problems. All right, so it is set to green, and I think it's inherited this from the Kayo, not Kayo. The Juki. Sorry, Juki nozzles are what's set in it, and you can see the settings in here are for that Juki nozzle. So when I created this nozzle, the wizard asks you what type of nozzle is it, and the option is to set a Juki, was what I selected, and it automatically puts in all of the settings for the color of the thing. Okay, so it already knows what the nozzle type is, and you can see on this little scale here, that little green band just there, that is what these settings have narrowed this down to. So that's what it thinks the color of the nozzle should be. So it's possible that this isn't correct. Maybe I need to expand this hue a little bit.
Johan Dunnison says maybe calibrate and optimize with doors, lid close.
Yeah, probably. In the past I found that it doesn't really make much difference, but in general I probably should. So maybe what I could do is if I expand the hue setting a little, it might be more sure of capturing the green that is the... So let's go from 93, let's change it to, I don't know, 70. Come on, can I change it? No, it's not letting me edit it. That's weird. Maybe that is just derived. Does it come from here? Can I change any of this? Oh, tolerance. Maybe I can just increase the tolerance. 8. Let's make it 16. And saturation 16. Value. Yeah, I'm just increasing the its masking at this point. So because parts are generally not green. They're usually white underneath, like or silver, or in the case of capacitors they're beige, but they have silver pads on them, so nowhere near green. And if I go back into the camera, I'm going to turn the brightness back up just a little bit. It's currently minus 87. I'm going to turn it back up a little bit to like minus 70 or so, so that it's going to bring the brightness back up on that camera. And parts, I'm going to grab a part again and get it back on the nozzle. What I could do is just rerun this board. If the objective here is to get this board finished, and I've got like 7 minutes until the stream ends, then I should just grab the board out of the machine and hand place any parts that are missing. But let's pick up this part and run this pipeline again. Whoa, that looks pretty freaky. What happened there? That is really freaky. What is with that pipeline? Hang on, we're not even looking at the right camera. No, look at this. It's looking at the down camera. Why didn't it change? Oh, okay. I know why. It's because I'm an idiot. That's why. What I should have done is gone into packages, 0603, and then done a test alignment. That will switch cameras on me. That's better. Okay. Edit pipeline. Okay. So that time it's found a much bigger thing. Where is the contour? Yeah, it's found a little reflection off the corner up there. If we come back up to here, is my custom mask circle still in there? Yes, it is. Yeah, so the interesting thing would be, just to see what happens, I am going to go and close the door in the machine. I'm going to leave it on that view while I walk into the other room.
Said Steve and Steph, proof of life.
Okay, I will do that, Peter. So I'm going to close the back and front doors of the machine. Don't know if that makes any difference at all, but it'll be interesting to see. Alright, so now let's see what it's doing. I'm going to rerun the pipeline threshold. No, I think it's still going to see the little thing up in the top right corner. Find contours. Come on, contours. There it is. It's actually found an extra one now. So each time it's run, it can change. Like if I keep clicking this, you see how that that picture is changing? Each time I rerun the pipeline, very slightly varying lighting conditions causes that to change. Yeah, okay. I'm going to have to screw around. This is one of those things that is just going to take time for me to go through the docs. I have been resisting sitting here reading the documentation again while I was on a stream, as Mitchell keeps telling me I should be doing. I've been resisting that because that's not exactly fun to watch.
Peter Lawler said TBF OpenCV is garbage.
Is it really? It's I certainly couldn't code something that that works as well as this. What am I doing? What am I doing? Okay, I think what I'm going to do is I'm
Mitchell
going
said
to
do it. It will be like Prime reading articles. Haha.
Machine setup. I'm going to change this brightness down again just a fraction, not as far as it was before, just to like minus 80. Yeah, minus 81, that'll do. Come back into Vision and edit that pipeline again. Yes. And now hopefully we're more of a happy medium where it's going to find contours there. And if I keep redoing that, yeah, that is probably a bit better.
Peter Lawler said by that, I mean it is so very easy to stuff up things that are genuinely very simple.
Oh, okay. Yeah, it's beyond me. It's beyond my pay grade, that's for sure. So now, back to the job. I am just going to rerun this job, and hopefully it will pick up the parts that it failed to place on the first time through. So it's just found something, whatever that was. I wasn't paying attention. 24K9, and next is the it's failing to pick up the voltage regulator. Oh, I know why that is. It's because the it's a problem with the feeder for the voltage regulator, so I shouldn't even be trying to place that one. So I'm going to come down here and turn that off, and let's see.
Peter Lawler said Johan suggested turning off the lights in the room.
Yeah, turning off the lights in the room. That might maybe. The machines are reasonably enclosed. Like once the covers are down, room lighting shouldn't affect it. It is quite fairly effectively enclosed. So I'm not going to bother trying that now. Okay, so 51 out of 51. I'm just going to try running again. What's it going to try to pick up? Yeah, it's failing to pick up the CAN transceiver. That's all right. I don't know what's going on with that. That might be a feeder issue as well. So it thinks it's put down all of the parts. Next, I am going to... What am I going to do? Next, I'm going to go back to camera view. As you can see, the cover is closed on it. and grab the board out of it and see what parts I need to put on by hand. Yoink!
It cannot.
Should? It shouldn't is doing a lot of lifting. Yeah, that's right. Shouldn't.
System notification, 15 minutes remaining.
That was a 15-minute warning at the time that the stream is meant to be finishing. So let's go gadget microscope. And let's, hang on, got to zoom way out because it was zoomed in for inspecting the quality of the solder paste. And I need to start putting some parts down. All right. Yeah, hang on. I will show you a bit of a screw up here. So if we come up this way, look at this. Look at the angle. This here, that is because it got the bounding box dramatically wrong on that. That is the transient voltage suppressor on the CAN bus. So I'm going to fix that. We saw that there were a couple of parts that it tried to put down. Oh, and down here.
Said, "Rip Steve and Steph."
Okay. I'm going to show you Steve and Steph. Here's Steve and Steph. Yes, they live. They still live. I'll have those down on the bench watching me do this. So a couple of the capacitors as well, the 0805 parts, it seemed to be having trouble with. So that pipeline definitely needs some checking. So there you can see here that those parts are misaligned quite badly. That one you can see that it misaligned. This one just here. So the bounding boxes that it was detecting on those parts were way off. Okay, now I need to, where's Steve? Actually, since Peter was asking for Steve, where's Steve on this? Where is he? There he is. There's Steve. And there's something odd about Steve. Also, I just remembered I need to, so I'm just going to do a quick scan across the board. Anything too badly aligned? No, not really. Okay. It's been a whole lot of stuffing around to get to this point, but I don't think it'll take all that long to finish this off. So I'm going to do this, but in order to reflow it, I need to get the reflow oven up to temperature. So I'm going to switch to this camera and go for a little walk again. And we're going to go and check out the Bernie Boy 3000. And got to turn it on. And input, program 12, and run. So it'll now be starting to get up to temperature. In fact, as a cheat, I'm going to put the camera here and leave it. I'll zoom back out. There we go. Because what we can do is look at see the little minus sign that's flashing there. If it's down on the bottom, that means that the temperature, it's under temperature. If it's in the middle, it's on temperature, and if it's at the top, it's over temperature. And so none of the zones are up to temperature yet. I'm going to leave that camera pointing at that display because then I can pull it up anytime I want to from my desk. And go back to the microscope. So I need to put down some 30 ohm resistors. Sadly you can't see this at the moment. If I go to, well, I could make it so you can see it. I'm going to bring this up here, close that, Move that, switch to that. Okay, so this is the board layout in Fusion. Now you might note I slipped in a little Easter egg. You might notice something strange about Steve. What's going on with Steve's face? I've got no idea if this is going to work, but there is something silly that I tried to do with Steve. So I need some 30 ohm resistors. Where are the 30s? I need 30s, 30s. There. Okay. So, can't pick it up. There. I'm not looking through the microscope at the moment. I'm trying to work around it, but leaving the microscope pointing at the board so that you can see what's going on.
Peter Lawler said pew pew.
Yeah, I think Peter's got it. I've done it in a kind of dodgy way though. What's happened to the focus? That's better. So 30 ohm resistors on there. I wonder what is on here. What are those? And there's meant to be a crystal here somewhere too, I'm sure. Oh yeah, there's meant to be the oscillator. Okay, so what are those parts? They are... Oh, they're also 30 ohm resistors. Yep. So there are... and where are we? There. And... there. 30 ohms. Then up here, this is, I think it's a 48 megahertz oscillator. I can't remember. I'm gonna have to look that part up. Okay, I need a 1.5K just above that oscillator. And I might as well get it out now since we've got it in focus and it's got to be put down anyway. It is, yes, it's a 48 megahertz oscillator. It is that. So, oscillators. 48 megahertz MEMS oscillator. I think that's the one. SOT 753, that doesn't sound right. That looks more like a... Yeah, it's a SOT 23.5. Why is... I may not be looking at the right part here. This might be an oscillator that I got for a totally different purpose. And... oh no, it looks like it'll fit. Okay, my guess is it will still fit. And it may even still work. That, yeah, that fits. It's a little bit skewed. I am struggling so hard with not fixing that alignment. It's breaking my mind. I'm going to try to leave it there. I'm going to try to leave it and not fix it. Keep it skewed so that it will pull itself straight under reflow. Alright, what other parts do I need to put on? What else is missing here? I need the USB hub IC, of course. USB hub IC. Here we go. How many of these do I have left? Can't be many. Oh, I've got 6 left. That's alright. Heaps. It's not like I'm going to be making many of these boards. So that is plenty. And we want it approximately there. Alright. I'm rushing now. Okay, so it missed a cap in there. It's just a filter cap. It's not like it even really matters that much, but I'm going to chuck it on anyway. Grab myself a 10 microfarad 0805 out of my mixed parts. Oh, you can see that the body of it is a slightly different colour to the others because it came off a different reel. That's out of my mixed parts thing. Then I need that. That'll be a fuse. There'll be a few fuses.
System notification. 5 minutes remaining.
The timing is way off. Fuses. I need a... Oh, I know. They're not there. They were being used a couple of days ago. They're over here on the bench. This is a polyfuse. And I'm going to need, how many of these? I'm going to need 3, I think, because we put one on the upstream power coming in, and we also put them on downstream power going to USB devices that are plugged into the... Hang on, I'm going to move this because it's been out of your view. Where's Steve? Remember we made Steve sit on the fuse? There we go. So the fuse is now in place. Steve is sitting on it. The fuse is upside down. Okay, I got to change that. I can't live with that. I've got to rotate the fuse so the marking is up the correct way. Only because Steve is sitting on it. Otherwise it wouldn't matter. There we go. Steve is sitting on the fuse. Now I need... Oh, I need that. And that is a little signal diode. Where are the signal diodes? We had those out recently as well. They might not be back in place. Nope, maybe they did get put away. I think I had a whole reel of those. Where did the signal diodes go? I don't know. Because I could use one of these. MD914. Yeah, it's the MMDL914 is what I'm looking for. I know I have an entire reel of them, but it's not in a machine. And it was used... Oh, okay, I might have put it away in a box. I might have even put it in the box that it is meant to be in. Which would be ridiculous if I had. It doesn't look like it. I can't see them in here. No. Where did they go? Without that, the WS28 13 won't work. So, I can fudge it. I have a signal diode of a different size. It doesn't quite fit on that footprint, so I'd have to buzz the track a little. But that might... Oh, I think I might have found where they've gone. Yes, I did. Oh, looks like Tyra cleaned up and organised and put the parts actually in a sensible place. All of the parts that have been used, the extra reels, were stacked on the shelf over the workbench, which is a very sensible place for them to be. Oh, hang on. Which footprint did I use? Ah.
Paula said 5 p.m. and John's still going.
Yeah. Ah. It was... I actually put down the footprint for the other... Will I use this one? Nah, stuff it. I'm going to grab the other... I'm going to grab the other signal diode. I've also got some 1N4 there is one in 5819s, which are in a SOD 123 footprint. And it looks like I put down a SOD 123 instead of a SOD 323. That's kind of annoying. Hang on, here we go. This one and this one. That's better. Okay.
System notification. Stream is over.
No, it's not. So I put this one down. I put down a 5819 instead of a 914. Functionally, it'll do the same thing. It's just a little low power silicon signal diode. All I wanted to do is drop a few fractions of a volt. So this one I'll just chuck away. I've got a whole reel of those. I don't care. It's not worth my time to do anything with it. So this is the CAN transceiver. I need to grab one of those. And what is the part that's just below that CAN transceiver? I think that might be a resistor. It's a 10K resistor. Why wasn't that put down? That indicates to me that I have screwed up somewhere when I was doing my part assignment in OpenPnP. Ah, no, that'll be one that it misdetected. It thought that it put it down when it didn't. That'll be the reason. Okay. So up here, what goes there? Oh, transient voltage suppressor. Okay. That's my guess anyway. It'll be a surface mount. Oh, polyfuse, rather.
Said it resisted putting it down.
Sorry, what was that? It resisted putting it down. Yes, it did indeed. All right, this is a MOV. Sorry, I was saying the wrong thing earlier. That is a MOV capable of taking a 1000 amp surge. But for such a tiny fraction of a second that the total energy is not that big. What's it rated to? It'll be a couple of joules probably. Don't know. Yeah, it's probably like 1.9 joules of energy or some ridiculous amount, but only for a tiny period of time. We're getting there. We're getting there. All right, I've got to put down a couple of voltage regulators. There I need an AP2112K, and where did they go? And I need an LM38010, which I have here. I'm going to need an inductor to go on that, to go with that, which I have here. I'm rushing now. Over 9,000. 1,000. Undernet systems. Okay. Here is, any moment now. Here is the LMR3. Is it right way around? Where's the orientation dot? There it is. There is the 38010. And I'll grab the inductor that goes with it. There. Inductify. Now I still need the AP2112K regulator that goes there. And they are not in my regulators box. I know that there are plenty of them in the pick and place machine, so I'm going to go and extract one from the machine. Pull it out of a feeder. Which feeder is it? That one! Okay. Grab that. Now, while I'm doing this, I have a feeling, what's the date today? We are now into December, aren't we? Which means this is the first Sunday of the month. And amazingly, that means that Barbecue Day is next Sunday. That has come around so quickly. All right, what else do we need? We need a snoot button. We need the CAN transceiver. We need a USB connector and some caps. More than 5 minutes. It's now 20 past. Alright, I've got the piezo. I'm not going to put that down just yet. I'm going to put some Kapton tape on it. What else am I looking for? Oh, that's right. I needed to get a reset button. Reset buttons are out here in a little drawer. No, it's not the reset button, it's the snoot button. Right. Snoot button going on. Where? There. Okay, snoot button is on. Yeah, I keep coming back to this. CAN transceiver. I've got to get that one. That also...
said time is an illusion. Lunchtime doubly so.
Yes, thank you, Mr. Adams. I believe it was Douglas Adams who came up with that one. Now, where? CAN transceivers. Are they in the machine? No. Okay. I've got to get these out of... Is that it? Nope. Is that it? Yes. That whining noise that you can hear coming through, that is the reflow oven complaining to itself. It's only complaining to itself because I'm not listening. I'm not paying attention. I think it's whining in the conveyor belt. It's a little bit of friction or something going on. Alright, so that's the CAN transceiver. How close are we getting? Very close. Very close. I need a USB-C socket to go on there. That's right, I said that I was going to put some solder paste in those holes and do a paste in hole thing. I'm going to turn the board upside down just to make it easier to get to that part of it. Squirt some paste there, some paste there, there, there. That'll do. And now I've got to chuck a USB-C connector in there. What do I have? Okay. USB-C. Yoink. Gadoink. Very good. I don't think I've got any of the quick connector style things. Those JST connectors, whatever they are. Yeah, so we're down to the last couple of things. There's the S3. I might as well put that on. I've got those around here somewhere. At least I thought I did. I'm down to my last couple of S3 modules. I actually need to order a heap more of these. Where did I put it? I specifically got it out earlier before the stream. Yeah, I've got 3 S3 modules left. I've gone through heaps in the last few days because we've just been doing an assembly job for a client. One of my clients' boards uses S3 modules. So we went through heaps of them. So Tom and Tyra were doing the assembly on those boards. Okay, so S3 is on. I need to put on the
Call the
little
ESP
piezo.
police.
Call the ESP police. Here we go, Kapton tape. So what I am about to do,
Call the ESP police.
call the ESP police. Okay, what I'm going to do is put a bit of Kapton tape on the top of this piezo. I don't even know why I've got a piezo on here. I think it was kind of, yeah, it's to indicate errors or give some kind of feedback, but I think it was kind of one of those things where it's like, oh yeah, I should have some kind of an audible feedback thing on it, but didn't really have a specific plan. So I'll stick that on there. That Kapton tape, that Kapton tape just prevents it from melting in the reflow oven. Chuck the tape back in the box. Chuck my S3s back in the anti-static bag. The two that I have left. And now, I think it's just the big caps. That's all I've got left to put on. So I just need 3 large electrolytics. And those are sitting here up on the shelf.
Mitchell last said you need to play the Star Wars tune when it starts up so you know it's booted and connect to happening.
Play the Star Wars tune, yeah. I wonder if we can do anything with the piezo, because it's got a built-in driver. It's not a so I don't know if we can properly like PWM it or anything. Unfortunately, I'm out of the low profile electrolytic caps, so I'm using these ones which are large and annoying. Okay, so looks like the oven is up to temperature, which of course it should be by now, and I can't see any other parts to go on the board, so I'm going to chuck it through the oven. I'm going to go for a little walk and then move the camera. Oh, as I was walking out of the room, I heard something being said on chat to speech. There we go. Board is slowly proceeding into the oven. It's a very slow motion conveyor belt. So that's going to take, I think, about 6 or 7 minutes before it comes out the other end. And this phone is complaining that its battery is nearly flat because running Droid Cam like this just rips through the battery. We're going to bring it back through here and plug it into a charger in the meantime until we need it again. And look, there's a big mess on my bench now. Steve and Steph are there, and all sorts of other random bags and packages and things. After doing assembly, I've got to clean everything up. All right, unplug that, plug that in. Whoop, this cable is power going to the phone, which is running as a camera right now. And there we go. Okay. Now I've got all these random reels and bags and things to get rid of. So that's right, that's what I was saying earlier, is I do believe that next Sunday is the barbecue, which seems super close. It doesn't seem like it was that long since the last one. No, I don't think it was that long because of the, what's the date today? So it's the 3rd of December. Okay, so the first Sunday of the month sort of falls into the early part of the month. And last month, I think the first Sunday was in the later, like it was late-ish. So the result is that the gap between the two barbecues, I think, is 1 week less than it has been other times. But that'll be the last, in fact, it's going to be the last barbecue for 2023. Woo. Barbecue after that is going to be 2024. That does not compute. Nope, my brain rejects that. I do not accept that reality.
Peter Lower said, "By John, new H-Bomber guy has dropped."
The what, who, where now? H-Bomber guy has dropped. New HBO.
System notification. Peter
what?
is super hangry. 15 minutes ago.
Where am I? Okay. I'm going to
Mitchell R. said, "Oh my God,
get rid of these.
I do not believe it."
Yeah, Git pull 2023. Oh, yes. Stephen says, will John make it back to the oven in time to stop the board from ending up on the floor? It won't end up on the floor. It will. There is a cardboard box
Right there.
just off the end of the conveyor, filled with DigiKey packaging. It's that perforated paper, you know, the stuff that they roll up and yeah. So what happens is the board comes off the end and it just lands on the packaging. Oh, Peter just sent me a link. One of the best 2-hour tech docs you'll ever see by HBOM, that thing that was previously in the chat. I'm going to have to check that out. Okay. Well, I've been going for now 2.5 hours, and I think the coffee that I had immediately before the stream seems to have worked, because I've somehow just been talking for 2.5 hours while doing this stuff. What am I doing? Okay, I do need to do a little bit of a cleanup here. Steve and Steph. Oop. I had a dream. Okay, talking about barbecues and the barbecue. One thing I was just thinking, before the last barbecue, is I want to set up a few things, like a few fun things for people to play with at the barbecues. And so my friend Brian has he sent me a link to a design. In fact, I'm going to see if I can find this. He sent me a link to a design for a game that is like, okay, so remember the old Pong game, the computer game. So 2 paddles that go up and down on the sides of the screen, and the ball that bounces between them. You know, supposedly one of the first computer games ever made. And anyway, there is a physical version of that, but it's 4-sided instead of 2-sided. I'm just going to find the link to it. He sent it to me in chat. And and he asked if I could help him make one, and I said, hell yeah, let's make 2. Because I want one here for the lab as well. Where are we? Here we go. I'm just going to open this and then bring it up where you can see it. There. Hyperlapse is what it's called. This thing. So this play table is a physical representation. It's like a physical Pong game. And you can see here there are photos of a few different builds. Oh, someone's done a transparent one. That looks really cool. I like that. I haven't really looked at the different build types before to see what they're like. Let's look. Oh, this is like a Simon memory game color with all the different colors shown there. Let's see if I can find a video. Yeah. Can I full screen this or anything? Nope. All right. 2D air hockey. Yeah, that's right.
R said that looks like it will cause some bad words. Haha.
Yep. Punch on. Oh, I just heard the board fall out of the pick and place, fall out of the reflow oven into the box. So I'll go and get it in a moment. But just wrapping this up. So you can see here, these little things that go side to side. On your controller, you move your, whatever the thing is, left and right, and you can press a button to make it like pulse out, and so you can shoot the ball. And the idea is that it's like playing, kind of like playing Pong, but with 4 people. Sorry, had to cough for a second. And so he asked me if I could help him build one of these for the gym. So Brian is my jiu-jitsu instructor, and he just thought it would be a fun thing to have for kids' days and things, something to play with. And so I want to make one as well. Anyway, the point of all of this is the thought process of I want to make a few things like this that are fun to play with for barbecues, so that when the barbecues are on, there are activities for people to do. This, if I come back to, this looks like the same one, different video of the same game. Anyway, I'm going to build one of these, and in fact I'm going to build 2. Brian and I are going to collaborate, and we're going to build 2 of them. One of them will be at the gym, the other one I'm going to have here at the lab, so that we can play around with it and have fun at barbecues. And ooh, Scott says make an automatic player or 4 for it too. Oh yes, this would be such a good thing for automation, like a vision processing system that tracks the ball and then moves the whatever this thing is. I don't know what this is called. I keep wanting to call it a puck because it's round, but it's not the puck. It's the player's station. Hang on, I'm going to go and grab the PCB and keep talking. So where this is going is I've been thinking about different things that I could get to set up at the lab for people to play with. You know, just fun interactive things, so that there's something to do and discuss and play with at the barbecues. And you know that those sort of situations where you don't know if you're awake or asleep. I had a dream that I didn't know was a dream while I was having it, and it was oh, that's not going to work because I've unplugged that. All right, now the microscope should come back to life. There it is. Now, so I was in this dream, and someone was asking me about doing something at a barbecue, and I said, oh well, I've got a pool table at the lab, so what I should do is just bring out the pool table when we have barbecues, because then, you know, we could play some games of pool. And in my head, in the dream, it was like, oh, why didn't I think of that? I'll just bring out the pool table. And I was sure in my head that it was a real thing. And then at some point I woke up and I was thinking, I should just get out the pool table. And then I realized I don't have a pool table. I don't know why. It was like this crossover between the dream state and the reality state. In my awake state, I was remembering the dream and thinking it was real. But it wasn't. But anyway, just made me think I should also get a pool table. And whatever else. Okay, Alexa, please turn on bench 1. Come on. I need my soldering iron.
Okay.
Yes, there it goes. It just took a little while. Alright, soldering iron is alive. Now, I can already see, the reason I've done that is that I can already see that there are bridges.
Mitchell R. said those dreams are the worst lol.
In the back here, yeah. No, but the really weird thing was that it wasn't just the dream, it was the waking reaction to the memory of the dream where I remembered the dream and thought that I was remembering a real event. That's the sort of thing that really throws me. Okay, so hopefully that's got rid of any bridges. There may still be bridges in underneath. I'm just going to, because I solder wicked this, I've just taken out a bunch of solder. I'm going to make sure these really do have joints in them. And then I'll finish the optical inspection, the manual optical inspection of the rest of the board. It doesn't sit upside down very well. Oh, this pasting hole seems to have worked okay. It could do with a little bit more solder in there, but it looks like it has actually bonded those stakes reasonably well into the PCB, so it should be mechanically fairly strong. I'm just adding a little bit more and reflowing it a bit to make sure that that USB socket is not going to fall off when I stick a cable in it. It feels nice and strong. Alright, get off the Kapton tape. And are there any other solder bridges anywhere on the board? There's our USB hub chip. I don't think so. Everything looks good. I think I can just plug this in and try loading firmware. Can't see any bridges around the voltage regulator. There's a misalignment on that part. It's pulled across sideways. Oh well, that doesn't matter. So I need USB sockets in here, but even before I do that, I'm going to just plug it in and see if I can flash the board. Yeah, okay. So for that, I'm going to need Arduino. Show us the smoke. Yes. Let's see if we can let out some smoke. I want to do that. And Alexa, turn off the air compressor.
Okay.
There we go. Oh, haha. Don pointed out something that I should have done. Yes, I totally forgot that. Let's do that. And I'm just going to check here what, where did it connect? 2K2 LED, I didn't specify a color. I think I'm going to make it green.
The people demand smoke. We demand the smoke. Smoke.
Smoke, smoke, smoke. Yeah, we need some smoke. Alright, but before that, I'm going to switch back to microscope because Steve
R said, "Damn it, John, my she that shall not be named responds to you and not me."
There's sorry Mitchell, I can come to your place whenever you need me to turn something on or off. Alright, now I did a dodgy here. What you can see is a hole right through the middle of the footprint for that. So this is on the back of the PCB. There is a footprint for an LED. Now I do not have rear shining LEDs, so I'm going to be totally dodgy and just try to mount one upside down and hope it works. So I'm going to take this LED, I've got to turn it around this way, and so that the anode is to the right. I don't know if I'm going to be able to do this without melting the top of the LED, so I'm just going to try to stick the LED. Oh, come on, get off there. I'm going to try to stick the LED over the hole. Oh, come on, I'm going to have to bridge up more solder. And the LED keeps sticking to my tweezers. Alright. I'm going to really build it up. Put a large blob of solder there on that pad. Ah, come on. Tip over, tip over. Ah, where'd it go? I just flicked the LED. Oh, there it is. We'll try again. And reflow. Oh, come on. I feel so uncoordinated because I'm trying to put it on upside down, and that means that the pads are a long way away from the PCB, which means
notification stream is over GHAAA. I give up.
So I've got to bridge the solder up to it. Oh, I think that held, kind of. So we've got one on. Now, I very quickly did this.
Flux the LED.
Yeah, flux the LED, that would probably help. All right, no, I think I've got it. There we go. So I did this very quickly, right as I was
LED comrade has fallen.
sending
Here.
the boards off for production. And I didn't, if I'd taken a little bit more time at it, what I should have done is made this, what do I want? That one. Is made this so that the LED was controlled by a GPIO. But I didn't. It is just connected to the power rail. So let's plug this in now. Oh look, Steve's got a glowing green eye. I think it's probably a little bit too bright. Oh no, in reality it actually looks kind of good. But the problem is it's right near the power LED. In fact, I'm going to get rid of that power LED because, or am I? Yeah, I'm going to get rid of the power LED. Take that.
Evil Steve, run away.
No, it's evil Steve if the eye is red. It's good Steve if the eye is green. Come on, why can't I get that off? Come on. Anyone would think I'd never soldered before. There we go. Got it off. All right. Plug this in. There we go. So the power LED is now Steve's eye. It's green. All right, I'm going to get this across under the microscope so we can see it better. But that means stretching the USB cable, which means hopefully not pulling everything off the bench. And I'm going to zoom out a bit. There it is. There is Steve with the glowing green eye. That is so cool. That actually works really well. But I do wish that I had made it controlled by a GPIO because I could PWM it and I could make his eye blink and do fun things. Even better would be an RGB LED so I can make his eye change color. Sadly, I did not do that. This was just a really quick thing.
Must go red in programming upload mode or connected to PC mode, and green when else, like iRobot, haha. Yes,
that's right. Because it's a rule that in robot movies, robots have to show green or blue when they're in happy mode, and they have to go red when they're in evil mode, so that us, the viewers, can tell them apart. Now, what am I doing? Okay. Next thing is I need to flash some firmware, which means I need to find the firmware, OpenKayo firmware. Here we go. Just opening it up. I will get it on screen in a second. Okay. Now, what do I want? I want it to be an S3. So ESP30, oh come on. ESP32 S3, and once that finishes switching profiles, I need to, come on. Oh yeah, stop that. There is some dodgy library that I've installed that has an example that's misnamed and it complains about that all the time. Port, that one. Well, it's found it. That's a good start. CDC on boot enabled. Remember that, you stupid IDE. Why does it keep going back to disabled? All right, so upload. And we should be full, yeah. Okay, so it's a good sign that it came up. All right, so the whole point of this, the point of this revision, version 1.1, was fixing my stupid mistakes from version 1.0, including not enabling the extra port on the USB hub. And the ESP32 is on port 3. So the fact that it has just discovered it means that that fix worked, which is really good. What else can we tell? So looking at the board, we actually can't tell anything. We can't tell whether anything is doing what it should. The piezo, I'm not even controlling the LED at the moment. There's just no code to even use the LED. So I need to put on all of the rest of the headers, put on the fuse mount here, put on the CAN bus connection, put on the USB headers, put on the LCD header, and there's no code in for the LCD either. So there kind of actually isn't, oh, and there's a reset button as well. So there kind of isn't really anything else we can test apart from plugging it into the machine and driving it. Do you want to hang around long enough for me to try driving the machine? Yes, I think you do. Well, I don't care if you do. I'm going to do it. So I'm not going to put all of the headers on. What I'm going to do is put on just that header, which is the one that it needs to talk to the machine. So I need a 3-way pluggable terminal. There are the 2s, more 2s, 4s, more 4s. Where's the 3-way? 3-pin plugs, 2-pin, 3-pin, I need 3-pin right angle. Is that it? No, that's 4-pin right angle. Come on, everything except the one I want. 4-pin socket, 2-pin. They're kind of approximately in order, but not obviously not in order enough. What I'm looking at here is this huge box. This huge box of pluggable terminals in all different sizes. I need to find the 3-pin right angle sockets among this very big collection. I'm trying to resist pulling stuff out. I'm gonna have to. Alright. 4-pin socket, 3-pin plug, no. 2-pin socket, 5-pin plug, no. 4-pin plugs and sockets, more 4s. Oh, 3-pin socket, but it's straight. I want the right angle version of that. No. 4-pin, no. 5-pin, no. 5-pin. Come on. 2-pin socket right angle, 2-pin plug. 8-pin socket right angle. Everything except the one I want. I'm seriously beginning to wonder if it's not even in here. Where? What? Where are the 3-pin sockets? Oh, there, at last. That just about the last packet in the board. Okay. I'm going to unplug that. So I've got to get my phone back on charge again, because it may even be flat by now, and I want it working to be able to show the machine moving in a minute. Okay. Oh, now I've got bags of headers all over the floor. Okay. Relax. Bit of sanity. let's get this soldered on. So the firmware that is loaded on it now should be the same firmware that is running on the OpenKayo version 1.0 prototype board. It should be the same as the firmware that just assembled this board. So we should be able to unplug one board, plug the other one in, and then still be able to control the machine. And that's it. We've got USB, we've got comms. I don't care about any of the other stuff right now. I don't care about CAN bus or the main power connection, because that's going to be used over CAN bus. I don't care about the other downstream USB connections yet. I'm not using those right now. So it is time for us to go mobile and see if this is going to work. All right. Grabbing that. Grabbing this. Switching cameras in just a moment. Boink. Okay. So we're going to take this through into here. First person view. And then what can you see? Oh yeah, you can just see. So jog, park the machine. It's already parked. Disconnect from the machine. Okay, so now OpenPnP is disconnected, and down here, down there, I'll go around the back. Down here, where is it? There. So this is, and why is that LED green? I don't know. Okay, so I'm going to unplug that, unplug that. That is the version 1.0 board with all the patches on it. So I'm just going to put that aside. This is the new 1.1 board. Plug in the machine and plug in USB. And now we've just got the little LED on Steve's face. Hopefully it'll have identified itself as the same serial port in OpenPnP. So here we go. Let's find out if our work has paid off. Connect. No serial port. Ooh, that's a worry. Okay, machine setup. Drivers. OpenKayo. Yeah, this might be the... hang on, what was it? No, I'm not going to change that. That's ACM1. I'm going to try S0. Let's see if that one works. This might be the same problem. No, I don't think it's going to connect. This is probably going to be the same thing as we've had. Oh, maybe it did. Let's see if I hit home. Nope, it's not communicating. Yeah, remember I was having all the problems with USB not resetting and doing odd stuff. It's probably related to that. So, oh yeah, the other port has disappeared. Alright, I'm going to exit out of OpenPnP. Do I want to save? Yeah, save the job. Oh yeah, this is my pipeline that's been saved. Do I want to save that? Actually, I don't need to, because I backed up my OpenPnP config previously, so I will have that pipeline in the previous config. And I'm just going to restart. And yes, I know I can probably reset the USB subsystem, but hey, this is what I'm doing. Yes, give me Ubuntu. Lots of ACPI errors. Hopefully that's not a sign of the disk failing, although I do know that the disk in this is a little bit dodgy. So, yeah, if this doesn't work, I'm so overtime on this live stream, and I do have something else that I have to do. Yesterday, I spent several hours lying under a car in a wrecker in the rain, in the mud, trying to remove a transmission because my son wants to buy a manual transmission to put in his car, and we tried to get it out, and we were there until closing time at the wrecker and we hadn't got it out yet. Come on, Ubuntu, what are you doing? And so we've got to go back today to finish removing the gearbox, and what we're really hoping is that in the meantime nobody else has gone and taken that gearbox and finished off. So we did hours of work pulling lots of stuff off around it to get access to it, to the point of cracking the bolts on the bell housing, and just didn't have time to drop the gearbox. So it should be fairly close to ready to remove. Come on, come on come on Ubuntu. All right, so it should be fairly close to being ready to remove, and with our luck, someone will have gone there this morning and taken it out after we've done all the prep work. But I need to put on old clothes. Is OpenPnP starting? I don't know. I have a feeling that this doesn't actually launch OpenPnP anymore. Since I did the upgrade. OpenPnP. Yeah, since I switched to the dev version. Yeah, so I need to put old clothes on again, because I am once again going to be lying on the ground under a car in a wrecker's yard in the mud trying to get a gearbox out. Why isn't OpenPnP even launching now? So I can't really hang around indefinitely. Yeah, I don't care about that. Go away. Just launch OpenPnP. Well, this won't even launch OpenPnP now. That's a serious problem. I think I'm going to have to call it, because this stream is so far over time. Oh, what's it doing? The blinking has stopped. Does that mean... Oh, okay, it was just taking a really, really long time to open. Okay, machine setup. Drivers, because I do have to go. It is currently set to TTYS 0. This one is set to ACM 0. I wonder if it's ACM 1. Alright, I'm going to try unplugging the OpenKayo board, and we'll see which serial port disappears. Yeah, ACM 1. Okay, so I've got to select ACM 1 as the serial port for the OpenKayo board, and it should be back. There we go, and apply. Alright, now can we connect to the machine? And is my phone even still working? Maybe my phone... Oh, I think my phone has gone flat, so you can't see anything anyway. Okay. And you're probably telling me that in the chat, and I can't see it. Where's my cursor? Where is this? Yeah, it's turned into an audio stream. Alright, what I'm going to do is do that and that. Everything. Yes, everything gone dead. We're working on voice. Right, got it. Quota exceeded. That's alright. I can do something about this. What I'm going to try to do, I'm going to switch to that view, just so that there is something on the screen. It's not just black. Then I have to reset the password for VNC on the controlling computer, and just opening the settings window is taking ages. Oh, here we go. Okay. Remote desktop, sharing, yes. And save. Okay. Now we should be able to get back to, where are we? VNC client, and I want to connect to, oh no, I don't want that. I want connect to server, that, sign in, cool. All right, now at least you can see the view of the control system. All right, let's try this now while I'm sitting here at my computer. I'm going to try connecting, and then I'll try homing the machine. If this doesn't work, well, even if it does work, I really have to stop because it's now after 1 o'clock. It's taken a long time just to connect, so I think this is going to fail. ACM1, still waiting, still waiting. Yeah, oh hang on, did I just disconnect it? Maybe if I click it again, maybe I had connected it. I don't know. So TTY ACM1, yeah, that's the port. Okay, now let's home the machine. It's doing it! Look at this! In a moment you're going to see this camera view move. I can hear the conveyor running. It's homing the conveyor right now, and then it's about to, there we go. So we are now controlling the Kayo, and look, it's doing the run out detection on the nozzles. Nozzle 2, nozzle 3, nozzle 4. So run out calibration complete, and park. So we're now controlling the machine through that OpenKayo board that we just assembled. Yes. Oh, Tomo says, knock knock, food delivery. Is Tom bringing me lunch? Awesome. Okay, I'm about, okay. No, I'm not going to paste up another board, Scott. That's it. I am stopping now. We have now got to the point where we've assembled a board and tested it on the machine, and it runs. So, I definitely need to take a break. And yeah, well done, shot of dopamine. That's right, Don. We ended with a win. It's now 3 hours into the stream, but we got there in the end. Ah, okay. Thanks everyone for your patience. Thanks for coming along and sitting through this interminable assembly session. The template trick that Mitch used to make that laser cut stencil, that worked. I am really impressed with that. That worked very, very well. Because I've got access to Lachlan's laser cutter here, I can do that technique here. So I need to talk to him about exactly how he did it. I'm sure that there are subtleties in terms of things like power settings and things. There's a lot of experimentation that it would take to get it right, to cut the stencil properly and cleanly without burning it and overheating it. So I've got to talk to Mitch about how he did that, what technique he used, and figure it all out. And so next weekend, barbecue weekend. It's the last one before Christmas, so it's kind of going to be a Christmas barbecue, I suppose, or a happy Saturnalia barbecue. And hopefully I will see a bunch of you here. The last barbecue was really big. There were quite a lot of people turned up, more than I expected, which was good, very good. So let's make this next one even bigger. And I am going to go and see what Tom has got me for lunch. So thank you very much. Have an awesome week, and I will talk to you all soon. Bye.